Hi, I'm Anne. Have you ever wondered how particle shape affects how your materials behave? Do you know which are the best parameters to describe the shape of your materials? Well, it does depend on your materials and what you want to know, but these are three of the most useful shape parameters: elongation, circularity, and convexity. Elongation tells you how long and thin a particle is. The higher the elongation value, the longer and thinner the particles are. Elongation is a useful parameter for predicting how well materials will flow. More irregular or highly elongated particles will not flow as predictably as circular particles. They're more likely to get locked together and cause clumps. Circularity tells you how close a particle is to being a perfect circle. To calculate circularity, you take the area of a particle, make it into a circle with the same area, and divide the perimeter of that circle by your original particle's perimeter. If the particle is perfectly circular to start with, then the perimeter will be the same and the circularity value will be 1. Powders used for additive manufacturing need to pack together very tightly in order to create high-density parts. And this requires particles with very high circularity. So the ability to classify particles by circularity will enable additive manufacturers to quantify the quality of their powders to ensure that they're using the right powders for the right applications. Convexity is a way to measure the roughness of a particle surface. The best way to visualize how you calculate convexity is to imagine putting a rubber band around the particle and divide the perimeter of that rubber band by the perimeter of the particle. If your particle has a smooth surface, that rubber band will fit nice and snugly around the particle, and the value of the convexity will be close to 1. The rougher the surface, the longer the perimeter of the particle, and therefore the lower the value of convexity. Convexity is a very useful parameter for anything that's related to reaction rates, like dissolution. This is because a rough surface will have a higher surface area compared to a smooth one. So if you had two particles of the same size, if one has lower convexity, then it's more likely to dissolve more quickly. These are just 3 of the shape parameters that you can measure by automated image analysis on the Morphologi 4. In fact, the Morphologi 4 measures over 20 size and shape parameters for every particle that it measures. So I hope that's given you a few ideas about how particle shape can help you to understand how your materials behave and which parameters might be the best to help you understand the different processes. If you want to know more about particle shape, image analysis, and the Morphologi 4, visit us at malvernpanalytical.com.